most fuel cell systems depend on expensive precious metals. How do you walk away from that yet maintain that performance level? And so we've been able to do that using what would be very inexpensive metals like manganese, cobalt, and iron, as opposed to platinum, gold, palladium, and iridium. I'm Héctor Abruña. I'm the Émile Chamot Professor in the Department of Chemistry and Chemical Biology at Cornell, where I have been on the faculty for 42 years. My area of expertise is electrochemistry, sort of broadly defined, and over the years our research has encompassed a variety of areas. Most recently, the focus has been on batteries and fuel cells. A lot of the work that we do is in the development of so-called electrocatalysts. So a catalyst is something that makes a reaction take place with a lower input of energy. In the lingo of chemistry, it lowers the barrier for going from reactants to products. The more you can lower that barrier, the more efficient your system is. And so we have developed catalysts for the oxygen reduction reaction, which I whimsically in my electrochemistry course called God's collective punishment to electrochemistry, because it's a very hard reaction to catalyze. But we've made great strides, in developing catalysts for the oxygen reduction reaction in alkaline media using non-precious metals. In particular, we have this thing called the manganese cobalt spinel that has, in essence, the same performance metrics as the most expensive metal catalyst. And so that was a very, very big hit. And so it takes that cost component out of the equation. The question is, can you make systems that have enough performance and durability, to make them viable? And we have made very significant, advances over the last 8 years. So one of the projects that we have through the Abruña Energy Initiative in Puerto Rico, 2017, all of Puerto Rico was devastated by Hurricane Maria, and there was no electricity. So the project consists on building the infrastructure at an organic farm to have a resilient, sustainable electricity even after a hurricane. And so we're now in the early stages of deploying that, and we feel that it should be a model for how to electrify isolated communities. And here I should mention that even though I'm the face of the center, it's the people who do the work day in and day out who are completely responsible for any success that we have. So regarding the Dreyfus Prize in Chemical Sciences, that was truly a humbling experience when I got the call from the foundation. And as with all prizes, it's really a reflection of the people who've done the work, in my laboratories over decades. And these are enormously talented and dedicated and really loyal people. This is the most important thing that I will ever do. Those people then continue, in their own ways, their traditions, whether they go into industry, to government labs, to academia. And they're the ones really who will continue, developing new technologies. That to me is probably the most important aspect of it.